Hey guys, in geometry we've been talking about our different transformations. So we've had our rotation, reflection, translation, and all of those different types of transformations have kept our object the exact same size and shape. Today we're going to talk about a different one, dilation, that continues to keep the same shape but changes its size. Okay, so our dilation is going to be how we can enlarge or reduce the size of an object. So this is how we can make an object larger or smaller by the same amount. That amount that we're talking about, that we're making it larger or smaller by, is called our scale factor, and that was one of our kind of key words, or is the key word when we're talking about dilations. Our scale factor is abbreviated as the letter K. Don't ask me why. The letter K then kind of represents that scale factor. But our scale factor is always going to be dealing with multiplication, and it's going to be multiplying everything, both our x and our y values, for our points. Okay, so the scale factor is what we multiply. I'm going to underline because it is multiply, not divide. So what we multiply all values by. And again, this is what makes it larger or smaller. Okay, the way we can tell, so this is kind of the first piece, the way we can tell if it's going to be bigger or smaller is depending on if it is larger or smaller than 1. So if our k value, our scale factor, is larger than 1, then our object gets larger. This kind of makes sense, like logically, if I said I'm going to multiply something times 2, that number is going to get bigger compared to if I multiply something times 0.5 or a half, that thing's going to get a little bit smaller. Okay, same idea with our objects. If we're going to multiply it times something larger than 1, it's going to get bigger. Okay, with our other k value, got to change that. Our other pieces then, if it's between, our k value is between 0 and 1, object gets smaller. I did ask my students in class today, I said, well, what happens if our k value or our scale factor is 1? Well, if it's 1, the object's going to stay the exact same size and shape, because if I multiply anything times 1, it doesn't change that value. Okay. For us to find the scale factor, so this is the part that people are like, well, cool, I know what scale factor is, but how do I find it? Sometimes you can just look at the picture and you can like, hey, I know exactly what this thing is being multiplied by. Other times it kind of is a little more of a process, and you have to kind of figure it out that way. So the way we're going to figure out our scale factor, and this is kind of our formula here, is we're going to have k is equal to whatever our image is divided by our pre-image. Okay. What other students like to see this as, or they don't like image and pre-image, is kind of a little bit harder because they think of image and they're like, well, that's the picture, unless you say pre-image, and then they're like, oh, okay, that's the after picture. So what a lot of times people like to think of it as is it's your after picture divided by your before picture. Okay, that's how we're going to find our scale factor. All right, I'm going to move the desk over, so this might be a little bumpy here, to kind of show you an example of what you might be looking at when you see something growing or enlarging or getting reduced. All right. So here's an example, and this is the exact same ones we showed today in class. If you're looking at the practice sheet that I uploaded for dilation, this is questions number 1 and question number 5. I would not do question number 3 because of the decimals. Okay. So if I'm looking at these two problems, they said for this we're always going to go from A to B. That's going to be our values. Okay. So if I'm going from A to B, I look at this first one and say, well, A is the smaller triangle, I'm going to the bigger triangle B. So I know, and this is kind of what you should do before you do any problem, is say, well, is it getting bigger or is it getting smaller? Because then I know my final answer, K, should be either bigger than 1 or should be between 0 and 1. So for this one, I'm going from A to B, the thing's getting bigger, so I know I should get a value that's larger than 1. So the thing with this is I can pick any point. And any point that I pick, I just need to find the one that's the same on the other triangle, the other object. Okay? So if I chose here, this point, 4, 2, the same point on the other triangle, the bigger triangle, is up here. So I would say, well, I'm going from the 4 to the 8. Okay, that's my x values. Again, I don't care if you use the x values or the y values. I tend to use the x values just because they come first. What you do then, again, is the image divided by the pre-image, or the after divided by the before. So I would take the after, 8, divided by the before, 4, to get my scale factor. 8 divided by 4 gets me 2. So it's saying that I could multiply, or this thing is getting 2 times as large. You can check that by looking at your y values and saying, well, did I do 2 times 2? Does that get me 4? Yep. 4 times 2 gets me 8. It checks out. It has to work for every point. Otherwise, your scale factor is not actually your scale factor. So here, my answer is k equals 2. Okay. Example of one where it gets a little bit smaller. Here I have another picture where I'm going from A to B. Again, A to B. This one, I look at the picture and I can say, well, it's getting smaller. Okay, so A is the bigger one, it's getting smaller, so I know my value should be between 0 and 1. It should be like a decimal. Okay, so again, I'm always going to go from my after divided by my before. So my image divided by my pre-image. So my after would be 2.51, and my before was 5.2. So I can take either of those values, doesn't matter. So I'm going to take 2.5 divided by 5. If you do that in your calculator, they get you 0.5, or if it's a fraction, it'll get you 1/2. So I know my scale factor is going to be 0.5 or 1/2, which makes sense because we said it got smaller, so it's between that 0 and 1. This is kind of the general idea for our dilation. The only additional thing we did talk about is we're never going to use the 0.00 to try to find a scale factor, because anything times 0 just gets you 0. Okay. This is just, again, kind of the basics of our dilation. It should at least get you through the practice for today. If you have any other questions, feel free to ask me, whether that's in person or by email. I should hopefully have some other transformation videos up in the next couple of days. All right. Hope to see you soon.